Hello, good morning everyone, and a very warm welcome to the session. I am Sanjeev Kumar. I lead the Storage Center of Excellence at High Tech Vertical in TCS. Today I am going to discuss one of the hot topic, which is cyber storage, a security first storage approach. Recently, cyber storage has been placed in the Gartner hype cycle for storage and data protection technology. Very few vendors have developed a solution around the cyber storage. So broadly, we are going to cover the statistics about the cyber attack at the industry level, storage industry preparedness to handle the attacks. We are going to cover the attack surface for the data storage, attack vectors, and how the current storage systems are being protected. Then we'll discuss the gap which is being filled by the cyber storage, which is a proactive storage approach. We'll talk about the standards and guidelines for cyber storage. We'll discuss about the NIST Framework, National Institute of Standards and Technology, its tenets and zero trust architecture, which is very important. At the end, we'll map the NIST framework for the data storage and OEMs, ISV, which are being supported for some tools, and each state is and they are putting their tools, and then we'll conclude it. So if you will see this, ransomware remains one of the most serious cyber threats that enterprise face today. And it's getting worse. Some of the facts that in 2021, ransomware played a role in 10% of the data breaches, which is 2 times increase in over year on year. A little over 37% of the companies worldwide were subjected to some of the ransomware attacks. And some of the industries, if you will see, are majorly hit by the ransomware attacks are high tech, manufacturing, retails, these kinds of industries are majorly hit. As per the Gartner, in the next 3 years, 60% of the enterprise will require storage products to have integrated ransomware defense mechanism. So it's very important. So we'll talk about the basic security framework, which is built around the 4 primary services of the security. That is accountability, confidentiality, integrity, and the availability. This framework incorporates all the security measures required to mitigate threats to these 4 primary security attributes. That is confidentiality, authorized access and traffic flow protection using encryption for the data at transit and at the rest. What is integrity? Unauthorized alteration or deletion of the information or error detection and correction. Availability, unauthorized deletion of the data and denial of the service, which is one of the crucial we have seen in the ransomware attacks. And the accountability, logs of events that can be audited or traced for the security purpose. Now we are going to see that how our current system are being protected. Increased use of the networking in the storage environment. Storage device has become highly exposed to the security threats from a variety of the sources. Specific controls must be implemented to secure a storage networking environment. Threats that apply to the storage networks are application access, management access, backup, archival, and replication access. 3 security domains for a storage system environments. That means 3 points which are vulnerable for the attacks. We'll take one by one all of these. Securing the management access. So in this figure, if you'll see, most of the management software supports some of the CLI form, management console, or a web-based interface. Providing the management access through an external network also increase the potential for unauthorized host or switch to connect to that network. So if we have to secure that, currently we are using these secure communication channels like SSH, SSL, or TSL, transport layer security, which provides effective protection against the threats. Even event log monitoring help us to identify unauthorized access and the unauthorized changes to the infrastructure. Controlling administrative access to storage is very critical. If you will see in this figure, this is the basic architecture where in the SAN fabric, the storages are connected. There is a host A, which is using through the CLI console. There is a host B through which this management interface uh, uh, are uh, are deployed. And suppose if the host A are authorized only to access the storage array, and he wants to access this remote storage array, that is a threat. Unauthorized host who is trying to access to the IP network and trying to access to any of these arrays is also a threat. Host B, somebody can spoof the identity or elevate from the user to admin credentials and access all the networks. So these are some of the problems which are being currently controlled by administrative access to the storage. We use administrative access regulation and the various auditing techniques. In fact, lots of storage has mandatory third-party authentication directories like LDAP and Active Directory. And a robust role-based access control is very much important in these kinds of scenarios. If you will see these backup recovery and archival kind of sites, is the sample sites or basic architecture for local sites, which has an storage array which is doing the replication, and there is a DR site at the remote location. Unauthorized host can access to these DR networks and try to get the data from storage to replicate it to some other remote sites, or the media theft at the local site is also one of the critical issues. So protecting the backup and recovery and archival infrastructure also requires addressing several threats, include loading, spoofing the legitimate identity of the DR site, tampering with the data, network spoofing, and denial of the service attack, and the media theft. Such threats represent potential violation of the integrity, confidentiality, and availability. So let's see that example we'll take in network attached storage and see that how we are securing that access. So these are the NAS devices. Some of the Windows and Windows and Linux based clients or Unix based clients are trying to access. So how these are accessing. So we'll see this. NAS is open to multiple exploitation, including virus, worms, unauthorized access, snooping, and data tampering, because these devices are the network. So for doing the authentication, NAS, if NAS has to share a file, there are two types of Windows either through the Windows or through the Linux machine. On the Windows, they have given these Windows access control layers. Two types of access control layers are there. One is the discretionary access control, which determines the access control. Second is the system access control list, which determines the access needs to be audited if auditing is enabled. In the Unix based permission has been given for the read, write, and execute permission. And based on those permissions, we create the groups for honors and groups and all. So if we have to do this authentication and authorization, so NAS devices are using standard file sharing protocols like NFS and SIFS. Authentication requires logging credentials, look up on a network information server in the Unix environment. If we are using this Windows client, then similarly for the Windows client is authenticity by a Windows domain controller that houses the Active Directory. The Active Directory uses the lightweight LDAP to access the information about the network objects in the directory and Kerberos for the network security. It's a authentication protocol, network security protocol. You see this Kerberos. So Kerberos is a network authentication protocol. It is designed to provide the strong authentication for the client server application by using the secret key cryptography. In Kerberos, client gets a ticket for the service and the server decrypt this ticket by using its secret key. Host are the user that gets a service ticket for a Kerberos. Service is called the Kerberos client. The term, if you will see this Kerberos servers, generally refer to the KDC, Key Distribution Center. KDC implement this authentication service and that ticket granting service. The KDC has a copy of every password associated with every principal, so it is absolutely vital that KDC remains secure. In a NAS environment, Kerberos is primarily used when authenticating against a Microsoft Active Directory domain. Because NAS devices utilize the IP protocol stack, they are also vulnerable to various attacks initiated through the public IP network layer firewalls. That means we are using these network layer firewalls are implemented in the NAS environment to protect the NAS devices from these security threats. These network layer firewalls are capable of examining network packets and compare them to set of configured security rules. So this way, generally, this NAS system has been secured currently through these 5 things: access control layers, permissions, authentication and authorization, Kerberos, and network layer firewalls. Now we'll see this. Now we will see that what is a cyber storage. So as per the Gartner, if you will see, this cyber storage protects unstructured storage system against data ransomware attacks through the early detection and blocking of the attacks, and aid in recovery through the analytics to pinpoint when the attack started. And they're also saying that do not treat cyber storage product as an alternative to the backup, immutable watts, network monitoring, or disaster recovery. They are an additional layer of the protection, preventing large scale data encryption and deletion for the file system. So you are seeing that. So till now we have seen that how storage systems are data prone for the attack, and how they are being protected from outside of the storage systems, from application and network. Due to increase in the ransomware attack and work from anywhere concept due to the COVID, data needs the top protection within the storage, and it's to be protective. Cyber storage is a data-centric approach to implement the zero trust security model in your storage systems, combining the capability of number of different technologies. Cyber storage tightly integrates storage with security into the unified data protection that's designed around the data. Cyber storage incorporates a range of functions such as vulnerability scanning, active monitoring, and remediation to help to protect the data against the damaging impact of the ransomware and insider attack from both the structured and unstructured data storage. Cyber storage capabilities serve as a security control center for the storage, giving us the visibility and control across our entire data state. Cyber storage also incorporates other zero trust measures such as IAM, identity and access management, EDR, endpoint detection and response, and micro segmentation also, which provides data focused security response against the attackers who manage to bypass all the layers of the security. So that is the data storage. So if we will see this data storage, cyber storage is based on the NIST cybersecurity framework. We'll talk about the general NIST cybersecurity framework. It has the 5 phases, that is identify, protect, detect, response, and recover. So generally, so with the basic definition of these phases within the identity, they say that identify all the process and assets and data which needs to be protected. Implement appropriate safeguard and protection technologies to your enterprise assets. Continuously implement appropriate mechanism to identify the occurrence of the cyber security incident. Once it has been detected, then we need to develop the technology to contain the impact of the cybersecurity impact, and then immediately recover from the appropriate process to restore the capability and the services impaired due to the cybersecurity. So this is the general cybersecurity framework. But with terms of the storage, how all these stages can be read out, like in the identity phase, we have to view all the data across our data states. We have to manage our data security posture across all the environments, like both the cloud-based and the on-premise. We have to find out sensitive data which requires extra protection. We have to find out most secure location for sensitive data and migrate. Determine the highest priority data in case there is an attack in the protect stage. We have to adopt the zero trust architecture, that is trust no one. At each layer of the storage, we have to implement the security. Create a data protection strategy and plan. We have to use the encryption, data encryption, which is both in transit at the rest. We have to configure the air-gapped disaster recovery sites. We have to take the immutable backup and snapshot. We have to delete all the stale and unnecessary data that hackers might target. And we have to log activities and monitoring for all the activities and for the analysis purpose. You see in the detect phase with the respect to the storages, what kind of things we need to do? Identify the sign of the ransomware attacks early in the attack life cycle. Detect suspicious uses patterns such as mass read, write, delete activities, abnormal increase in the encryption, and user access outside the normal working hour. Identify unpatched vulnerabilities, identify misconfiguration and weaknesses such as unsafe file permission, monitor and control access privilege. Within the respond, so generate alert that signal attacks such as unusual system stress or loss of the storage efficiency. Quickly locate affected data in the event of the attack. Provide automated defense mechanisms such as session blocking. Provide actionable information about an attack so that you can quickly access the impact and take the appropriate measure accordingly. Recover within the recover phase. Recover quickly using the reliable and efficient backup copies. Provide forensic details so that you can establish the root cause analysis of the attack and impact future preventive measures. Access the damage with the file level forensics and identify which files to restore. Place data directly in the location where you specify at the block level. Locate last uncorrupted copy of the data needs to be restored. If we will see this identify, protect, detect, all these three phases can be automated, but respond and recover, these requires the human intervention. It's a combination of the automation and the human intervention. Maybe some false error or false threat has come to overcome those things. One of the core component of the cybersecurity framework is zero trust architecture to protect functions. Zero trust architecture components may be operated as an on-premise service or through a cloud-based service. So zero trust architecture logical components use the separation of the control plane to communicate, while application data is communicated on the data plane. So this is one of the architecture. We'll take one by one all the components, how it works, how needs to be implemented in our storage systems. There is a policy engine, there is a policy administrator, and there is a policy enforcement points. So what is a policy engine? This component is responsible for the detection to grant the access to the resource for a given subject. The policy engine uses the enterprise policy as well as input from the external sources like CDM, compliance, threat, activity logs, okay, as an input to trust the algorithms, to grant, deny, and revoke access to the resources. The policy engine makes the logs of the decision like approved, denied, and policy administrator execute those decisions. So what is the policy administrator? This component is responsible for establishing and are shutting down the communication path between the subject and the resources through policy enforcement points. It would generate any session specific authentication and authorization token or credential used by the client to access an enterprise resource. It is closely tied with the policy engine and relies on its decision to ultimately allow or deny a session. Policy enforcement point. This system is responsible for enabling, monitoring, and eventually terminating connection between a subject and an enterprise resource. The policy enforcement point. This is this one. This communicates with the policy administrator to forward request and receive policy update from the policy administrator. This is one of the important continuous diagnostic and mitigation system. This gathers information about the enterprise assets current state and applies update to configuration and software components. An enterprise CDM system provides the policy engine with the information about the assets, making an access request, such as whether it's running the appropriate patch operating system, the integrity of the enterprise approved software components, or presence of a non-approved component, and whether the assets has any known vulnerabilities or not. Industry compliances. This ensures that the enterprise remains compliant with any regulatory regime that it may fall under HIPAA or PCI SSD or FISMA. Okay, that kind of things. Threat intelligence. This provide information from the internal or external sources that help the policy engine make access decision. These could be multiple service that takes data from the internal and are multiple external sources and provide information about the newly discovered attacks or vulnerabilities. This also includes newly discovered flaws in the software, newly identified malware, and reported attacks to other such assets that the policy engine will want to deny access to from the enterprise assets. Network and system activity logs. This is the enterprise system aggregates assets logs, network traffic, resource access location, and other events that provide real-time feedback on the security posture of the enterprise information systems. Data access policy. These are the attributes, rules, and the policies about the access to the enterprise resources. This set of rules could be encoded via management interface or dynamically granted by the policy engine. Okay. So data access policies, on the right hand side, data access policies, these are the attributes, rules, policies about the access to enterprise resources. This set of rules could be enforced through a management interface or dynamically generated by the policy. Enterprise public key interface. This is responsible for generating and logging certificate issued by the enterprise to resource, subject, services, and application. Identity management system. This is responsible for creating, storing, and managing enterprise users account and identity record. This system contains the necessary subject informations like name, email ID, certificates, and other enterprise characteristics such as roles, access attributes, and signed assets. This system often utilizes the other systems such as PKI for artifacts associated with the user account. And last is system information and event management. This collects security-centric information for the later analysis. This data is then used to refine policies, and warn of the policy possible attacks against the enterprise assets. To implement a full zero trust solution, organizations should include enhanced identity governance driven logical micro segmentation and network based segmentation. So through this segmentation, this zero trust architecture at each level we have to implement, so that once has been bypassed by the threats or ransomware, another can take care. If you will see that what is a data centric zero trust models looks like. So in this, if you will see, at the center of this is our data. Okay, and on top of that, all the different ecosystems like application, host, and networks, perimeters are physical, and the governance and compliances. So this is a data-centric trust model where layered security architecture has been shown at each level, starting with the core, which is RBAC, robust role-based access control, multi-factor authentication, end-to-end encryption of the data at rest and in the flight, immutable data copies, air gap copies, secure retention, effective replication, storage, user behavior analytics for anomaly detection. It also includes early detection of the threats by malicious file blocking. For application accessing, the storage, uh, access control, authentication, password management, application vulnerabilities management, secure domain manager, which lets you manage your secure domain by securing tunneling through SNMP and ICMP traffic through a secure connection. If you'll see, all other layers such as host, networks, perimeters, physical and governance and compliance will be secure as usual. And every this ecosystem we need to set up around our data storages, and in the storage we have to set up very dedicated security service for our storage systems. One thing to remember, that physical security is also one of the very important for storage systems. If you'll see, there are multiple ISOs and NIST guidelines recommendation for storage securities, which OEMs and ISV are considering while developing their storage, cyber storage products. So this first one, 27040, talks about the storage security. It covers the authentication, authorization, access control, SCDE, self-encrypted drive, media sensitization, logging, fiber channel security, and OSS key management interoperability protocol. Second one, 209 security guidelines for storage infrastructure. It has been recently introduced in October 2020. It covers the security, threat, risk, attack surface, and provide guidelines for storage deployment for security. NIST SP 800-111 talks about the encryption technologies for end-to-end data flow, that is from in-flight to data at rest encryption. The data storage security is critical from a legal and compliance perspective. Data that organization may use for the legalization must be both secure and easily accessible. Some of the standard bodies who has created the protocols like SMIS, which is currently in 1.8, it defines a method for interoperable management of the multi-vendor SAN. Current version is 1.8. If you will see that XAM, Extensible Access Method Interface specification, which defines a standard access method, that is API between consumer and the provider, that is storage systems, to manage the fixed content reference information service. XAM includes metadata definition to accompany data to achieve application interoperability, storage transparency, and automation of ILM-based practices, long-term record retention, and information security. Data protection standards varies from geo to industry. Some of the standards like GDPR, General Data Protection Regulation, HIPAA for healthcare to protect the health record, and PCI DSS, information security standards for the card holder. So these kinds of protocols or security standards we need to follow while architecting or developing our storage products at each layer. So earlier we have talked about the NIST cybersecurity framework. Then we have told that how it is mapped to our storage systems. Here we are talking about that at each stages, what are the activities that we need to do, and what does that activities means. So if somebody has to design the storage systems, or somebody has to integrate their existing storage systems with these security features, how they have to do that. So first is identify where their vulnerability scanning is there. It enables cyber hygiene to validate best practices, security credentials like misconfigured items, open access, simple password, user credentials, security patches to minimize the risk. Next one is zero trust architecture in the product, where multi-factor and multi-person authentication to prevent the unwanted critical system administrative activities like permission changes or system deletion. Complete role separation between the admin and user for the system management and data access to prevent unwanted access by the admin. Logical layer gaps, which prevent access from unwanted systems and the user activities to access or change user data from within the system. Detailed logging, like user logs for all the users and admins, and system activities for monitoring and analysis. If you'll see this intelligent file indexing, indexing all the files for the various tracking and recoverable for the files across the snapshot. Immutable snapshot, create immutable snapshots for intelligent recovery, not identical to the default snapshot, as immutable snapshot integrate with the detection and recovery parts of the ransomware detection. Reporting. The reporting function is proof for the compliance and will let you take what action is needed. The reporting provide advanced reporting function for cyber behavior, including the strong visualization like heat map, access pattern, and suspicious changes within the configuration management. Next is anomaly detection, which detects any suspicious behavior of the system by correlating all the system monitoring activities that we have collected. Ransomware detects encryption and identifies ransomware. Malware detection detects and identify malware attached to a file. Detect extra data exfiltration detection, which detects loss of the data to prevent data extortion, where hackers steal data before encrypt. And one is alerting, where alert security officers and IT operations of the cyber activities. Session blocking, block an active ransomware session, but not the entire system. In the recover also, this forensic analysis, which provides deep and smart analytics after a cyber hit to identify the scope and root cause analysis of the attacks on the system. Okay, and after that, smart recovery, where simplify recovery of the data through integration with the index and snapshot to automatically recover the minimal damage that was done. If you'll see below are some of the sample tools for the products that are available in the market. They are products which are usually compliant for an NIST framework, and some products which are partial compliance. And they just a sample list. So till now we have seen the NIST cybersecurity framework, zero trust architecture for overall storage ecosystem, guidelines, standards for implementing cyber storage, and NIST framework mapped for the storage. If we are going to design cyber storage, we need to secure each layer of the storage with the latest protocols and compliance. Example, our storage ecosystem, our storage system says there any web interface through which we are trying to access some exposed API. Those APIs need to be implemented with REST, using the OAuth 0.2.0 authentication. Okay, and JWT which is JSON Web Token. For compliances perspective, access control report, storage profile policy, security, encryption, audit reports, user behavior, data protection, retention policies, change control auditing that are required for the security audits. Data storage services, if we have to implement these, we have to implement this inline compression, deduplication, immutable snapshot, block and file replications, file indexing, quotas, reservation, transparent data movement, and multi-tenancy. If we have to if we have to implement these client protocols, then latest version of this client protocols like NFS version 3, version 4.1, 4.2 are at security levels we have to implement, and latest SMBs protocols SMB 2.1.3 with FIPS 142 encryption needs to be there. Okay, so overall, if you will see that if we have to design our storage systems at each layer, from the management perspective, from the client accessing perspective, from the data storage perspective, from the security at each level perspective, we need to implement these things using this NIST framework, the guidelines that has been given, and our storage will be complied to the cyber storage and will be much safer storage to use. And at the end, backup and disaster recovery, these are the last line of storage protection. This cyber storage is an additional or extra layer of the protection which has been provided to our storage systems. So that's it from my side. Thank you very much.